Nuclear energy is the reason we have electricity in our homes, schools, and malls. In every atom, energy, or the strong force, binds the nucleus together. In order to gain this electricity used in our daily lives, atoms are split in a process called nuclear fission to release that energy. A nuclear reactor is a group of machines that controls nuclear fission to produce electricity. Uranium is the most popular fuel because this element splits the atom fairly easily and is commonly found in rocks everywhere. This uranium is mostly mined in Australia, Canada, Kazakhstan, Russia, and Uzbekistan. In Canada, about 15% of electricity is produced by nuclear energy. CANDU nuclear reactors, short for Canadian Deuterium Uranium, since it was designed in Canada. How do CANDU nuclear reactors work? CANDU nuclear reactors take advantage of uranium. Fuel for the CANDU nuclear reactors are little pellets that contain uranium oxide. The groups of pellets are inserted in long metal tubes that are welded together as a bundle. Large quantities of this bundle are grouped and put into the calandria, which is also known as the reaction vessel, to split the uranium atom. The uranium atom undergoes a reaction called nuclear fission, which is when a slow neutron, bang, collides with the nucleus, resulting in two lighter nuclei, more neutrons, and a large amount of heat energy. Remember those new neutrons that were as a result of the collision? They are super fast and must be slowed down. But how? To slow down the fast-traveling neutrons, a moderator is used. CANDU nuclear reactors use heavy water as the moderator. This heavy water is 10% heavier than normal water because it contains more deuterium, which is a form of hydrogen. The heavy water flows by the bundles to slow down the neutrons for a chain reaction of splitting the uranium atom. The heat caused by splitting up the atoms warms the heavy water. The heavy water is pressurized to prevent it from boiling and producing bad steam. The pressurized heavy water is used to heat regular water for good steam. See the difference? This steam pushes and turns the turbines connected to electric generators and produces electricity. The heavy water cools down and is recycled back into the reactor. CANDU nuclear reactors are beneficial because most other nuclear reactors require pure uranium that is mined, transported, and expensively enriched. CANDU nuclear reactors are able to effectively generate energy from a variety of resources such as natural uranium, pure uranium, sometimes thorium, and recovered uranium from old nuclear weapons or the waste fuel.
Although CANDU nuclear reactors have many great aspects about them, there are also some dangerous risks to consider. Radioactive pollution from CANDU reactors can lead to environmental and public health problems. Radioactive contamination is impossible to see, smell, or taste, and its life-threatening effects may take years to show up in the human body. The emission of large amounts of the radioactive element tritium is unique to the CANDU reactor because it is produced in great abundance by the exposure of heavy water to radiation. From 1989 to 1992, the 8 CANDU reactors in Bruce, Ontario released on average 4,500 terabecquerels of this deadly radioactive element. Extensive studies show that tritium fed to pregnant mammals is passed on through the placenta to the unborn offspring. Unlike most other radioactive materials, tritium can be directly incorporated into the DNA that controls the passing on of genetic material. In humans, the most common birth defect caused by tritium exposure in the womb is mental retardation.
Created using Powtoon.